When installing a transformer with a 208-volt single-phase primary and 240/120-volt secondary, and feeding it from an existing panel to a new panel, along with a manual transfer switch for a standby generator, the placement of the fuse disconnect on the secondary of the transformer is critical. The fuse disconnect should be installed before the transfer switch. This is to ensure proper overcurrent protection for the transformer and the downstream load. The fuse disconnect serves as an overcurrent protection device. Overcurrent protection should be installed as close to the power source as possible. This installation protects the transformer and connected equipment by promptly detecting and interrupting any faults or overloads on the secondary side. The installation sequence should be followed carefully. Firstly, connect the 208-volt single-phase primary of the transformer to the existing panel. Secondly, install the fuse disconnect on the secondary side of the transformer. Thirdly, connect the transfer switch to the output of the fuse disconnect. Fourthly, connect the load panel to the output of the transfer switch. This sequence positions the fuse disconnect upstream of the transfer switch. Doing so provides overcurrent protection for both the transformer and the downstream load. This arrangement ensures that the transformer is protected. It protects from faults originating in the transfer switch or the load panel. This is a standard practice in electrical installations. It minimizes the risk of damage or fire due to electrical faults. By placing the fuse disconnect before the transfer switch, you are protecting the entire system. Overcurrent protection devices are essential for electrical safety. They safeguard equipment and prevent hazards. The National Electrical Code, or NEC, provides guidelines for selecting and installing overcurrent protection devices. These guidelines should be followed to ensure a safe and compliant installation. The size of the fuses in the disconnect should be selected based on the transformer's secondary current rating. It should be in accordance with NEC requirement. The fuse rating should be adequate to handle normal load currents, but at the same time it should trip quickly under overload or short circuit conditions. This balance is crucial for effective protection. Selecting the correct fuse size is essential for safety. It allows for reliable operation of the transformer and connected equipment. A fuse that is too small may trip unnecessarily. A fuse that is too large may not provide adequate protection. Consult the transformer manufacturer's specifications. Also, adhere to NEC guidelines for proper fuse selection. When installing the transfer switch, make sure it is rated for the voltage and current of the system. The transfer switch should be listed by a recognized testing laboratory. The transfer switch should be installed according to the manufacturer's instructions. A proper installation is crucial for safe and reliable operation. Ensure that all connections are tight and secure. Use appropriately sized conductors for all wiring. The wiring should comply with NEC standards. Grounding is another critical aspect of electrical safety. The transformer, fuse disconnect, transfer switch, and load panel should be properly grounded. Grounding provides a path for fault currents. It helps to prevent electrical shock hazards. The grounding system should be installed according to NEC requirements. Check local electrical codes and regulations. They may have additional requirements for transformer and transfer switch installations. Compliance with all applicable codes and regulations is essential for safety and legality. Always disconnect power before working on electrical equipment. Use appropriate personal protective equipment, or PPE, such as gloves and eye protection. If you are not qualified to perform electrical work, hire a licensed electrician. Working with electricity can be dangerous. Always prioritize safety. In summary, the fuse disconnect on the secondary side of the transformer should be installed before the transfer switch. This ensures that the transformer and downstream load are protected from overcurrents. Follow the recommended installation sequence. Select the correct fuse size. Ensure proper grounding. Comply with all applicable codes and regulations. Prioritize safety at all times. This approach guarantees a safe and reliable electrical installation. Remember to consult the National Electrical Code, specifically Article 450 and Article 702. Article 450 covers transformers. Article 702 covers optional standby systems, including generators and transfer switches. These articles provide detailed requirements for installation, protection, and grounding. Adhering to these requirements is critical for ensuring a safe and compliant installation. Understanding the purpose of each component in the system is also important. The transformer steps down the voltage from 208 volts to 240/120 volts. The fuse disconnect provides overcurrent protection for the transformer and downstream load. The transfer switch allows you to switch between the utility power and the standby generator. The load panel distributes power to the various circuits in the building. Each component plays a vital role in the overall system. Proper installation and maintenance of each component are essential for reliable operation. Regularly inspect the system for any signs of damage or wear. Test the transfer switch and generator periodically to ensure they are functioning properly. Address any issues promptly to prevent problems. By following these guidelines, you can ensure that your transformer and transfer switch installation is safe, reliable, and compliant with all applicable codes and regulations. This provides peace of mind. It protects your equipment and the people who use it. Consider the specific application when selecting the transformer and transfer switch. For example, if the load panel will be supplying critical equipment, such as life safety systems, it's important to choose a transfer switch that is designed for critical loads. These transfer switches typically have features such as automatic transfer and bypass isolation. Automatic transfer switches automatically switch to the generator when utility power is lost. Bypass isolation allows you to maintain or repair the transfer switch without interrupting power to the load. These features can be essential for ensuring that critical equipment continues to operate during a power outage. Another important consideration is the size of the transformer. The transformer should be sized to handle the maximum load that will be connected to the load panel. Overloading the transformer can cause it to overheat and fail. To determine the appropriate transformer size, calculate the total voltamps of all the loads that will be connected to the load panel. Then select a transformer with a voltamp rating that is at least 25% greater than the total load. This provides a safety margin and ensures that the transformer will not be overloaded. When selecting the fuse disconnect, be sure to choose one that is rated for the voltage and current of the transformer secondary. The fuse disconnect should also have an interrupting rating that is sufficient to interrupt the maximum fault current that could occur at the transformer secondary. The interrupting rating is the maximum amount of current that the fuse disconnect can safely interrupt. If the interrupting rating is too low, the fuse disconnect may fail to interrupt a fault current. Doing so can cause damage to equipment or even a fire. In addition to these technical considerations, it's also important to consider the physical location of the equipment. The transformer, fuse disconnect, transfer switch, and load panel should be installed in a location that is accessible for maintenance and repair. The location should also be protected from the elements. Transformers typically generate heat. They should be installed in a well-ventilated area to prevent overheating. All of this equipment should be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. This ensures a safe and reliable installation. Remember to consult with a qualified electrician or electrical engineer. They can help you select the appropriate equipment. They can also ensure that the installation is performed correctly. This can save you time and money in the long run. It can also prevent potential hazards. Always prioritize safety when working with electricity. Understanding and adhering to the NEC is crucial for a safe electrical installation. The NEC provides detailed guidelines for selecting, installing, and maintaining electrical equipment. It addresses a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. Familiarize yourself with the relevant sections of the NEC before starting any electrical work. This can help you avoid common mistakes. It also ensures that your installation meets all applicable safety standards. The NEC is updated every 3 years. It reflects the latest advances in electrical technology. Staying up to date with the latest edition of the NEC is important for all electrical professionals. This ensures that they are using the most current and accurate information. In addition to the NEC, there are other resources available to help you with your electrical installation. These include manufacturer's instructions, technical manuals, and online forums. Utilize these resources to expand your knowledge. Also, get answers to any questions you may have. A thorough understanding of electrical principles and practices is essential for a safe and reliable installation. Remember that electrical work can be dangerous. It should only be performed by qualified individuals. If you are not comfortable working with electricity, hire a licensed electrician. They have the training and experience to perform the work safely and correctly. Investing in professional electrical services can provide peace of mind. You will know that the job has been done right. It will meet all applicable safety standards. Finally, document your electrical installation. Keep records of all equipment that you used. Also, keep records of all inspections and tests that were performed. This documentation can be helpful for future maintenance. It can be helpful for repairs and for any future modifications to the system. Proper documentation also demonstrates compliance with applicable codes and regulations. It can be valuable in the event of an insurance claim. By following these guidelines, you can ensure that your electrical installation is safe, reliable, and compliant with all applicable standards. This protects your equipment. It also protects the people who use it. This comprehensive approach to electrical safety and installation best practices will minimize risks. It optimizes system performance and ensures long-term reliability. It is important to understand the concept of short-circuit current rating, or SCCR. The SCCR is the maximum fault current that a component or assembly can safely withstand without failure. All electrical equipment should have an SCCR that is equal to or greater than the available fault current at its point of installation. This is critical for preventing equipment damage and personal injury in the event of a short circuit. The available fault current can be calculated using engineering methods. It can also be determined by contacting the local utility company. The SCCR of electrical equipment is typically marked on the equipment nameplate. Be sure to verify that the SCCR of all equipment is adequate for the application. When installing a transfer switch, it's important to consider the grounding and bonding requirements. Grounding provides a path for fault currents to flow back to the source. Bonding ensures that all metal parts of the electrical system are at the same electrical potential. This minimizes the risk of electric shock. The NEC provides detailed requirements for grounding and bonding. It is essential to follow these requirements carefully. Improper grounding and bonding can create a dangerous situation. This can result in electric shock or fire. In addition to grounding and bonding, surge protection is another important consideration. Surge protection devices, or SPDs, protect electrical equipment from voltage surges. These surges can be caused by lightning strikes, utility switching, or other events. Voltage surges can damage or destroy sensitive electronic equipment. SPD divert surge current away from the protected equipment. They protect them from damage. SPD should be installed at the service entrance. They should be installed at any subpanels that feed sensitive electronic equipment. The selection and installation of SPD should be based on the specific application. Follow the manufacturer's instructions and all applicable codes and regulations. Regular maintenance of electrical equipment is essential for ensuring reliable operation. Perform routine inspections of transformers, fuse disconnects, transfer switches, and load panels. Look for any signs of damage, overheating, or corrosion. Tighten any loose connections. Clean any dirt or debris. Test the operation of the transfer switch and generator on a regular basis. Replace any worn or damaged components. Proper maintenance can extend the life of electrical equipment. It can also prevent costly repairs. When working with electrical equipment, always follow lockout/tagout procedures. Lockout/tagout is a safety procedure that prevents accidental energization of equipment during maintenance or repair. Before starting any work, disconnect the power source. then lock and tag the disconnect switch. This prevents someone from accidentally turning the power back on while you are working. Only authorized personnel should be allowed to remove the lock and tag. Lockout/tag-out procedures are essential for preventing electrical accidents. They should be followed every time you work on electrical equipment. In summary, a comprehensive approach to electrical installation includes proper equipment selection, compliance with codes and regulations, attention to grounding and bonding, surge protection, regular maintenance, and adherence to lockout/tag-out procedures. This approach ensures a safe and reliable electrical system. It protects equipment and the safety of personnel. Always prioritize safety when working with electricity. Seek the assistance of qualified professionals. Stay informed about the latest codes and regulations. By doing so, you can minimize the risks associated with electrical work. You can ensure a safe and reliable electrical system for your facility.